Hello, in this video you will learn what types of statements can be proven by induction. Let's start. What kinds of statements can be proven by induction? And what is the answer? Well, the answer is that these will be statements or theorems, formulas, inequalities, anything, holding for all natural numbers or just for all natural numbers starting with some natural number and 0. So the 0 is just an index, don't worry about it. It denotes just some starting point. From this number, for all the other natural numbers, some statements should be true. And you know the natural numbers are starting from 0. Natural numbers are integer numbers which are positive or 0. So these are natural numbers. And some statements which we are going to prove will be holding for all the natural numbers, so for all of them. And some of them will just start with some particular number and will hold for all the next coming numbers. You will see examples of this, so don't worry. And here, our statements will be often called T of n. So, I will always call them T of n, but some other teachers could call them P of n or S of n, and all these letters represent some words, like T is thesis, P is proposition, S is statement, and there is actually no difference between them. You can use any of them, but I just want to give you several possibilities because it is possible that your teacher will use another letter than T. I'm used to the letter T. So our theorems will often look like this. Prove that some statement T of n is true for all natural numbers n, or sometimes will stand for all natural numbers n greater than or equal to 3. Then you know that this 3 is your n0, right? And now, it looks probably strange to you, so I have prepared several examples of such statements. So how can such a statement look? For example, this is a statement about a number n. N squared plus 1 is greater than 0. And obviously this statement will be true for all natural numbers, because you see, a square of a real number is always non-negative, it's always 0 or more, and if you add 1 to this, it will be a positive number always. So this is a statement which is always true for all natural numbers. Another statement can be the following: n squared is equal to n minus 1. And you see, this statement is clearly not true for natural numbers, right? If you take 0, then it would read 0 is equal to minus 1. If you take 1, it would read 1 is equal to 1 minus 1 is 0, right? And then for the next numbers, for number 2, it will be 2 squared is 4 and 2 minus 1 is 1. So this will never be true. So a statement T of n is just some statement for natural numbers, and it sometimes can be true for all natural numbers, as this one. Sometimes it can be false for all natural numbers, and sometimes it can be just true for some natural numbers. So the next statement is the following: T of n, which tells you that the sum of all the natural numbers from 1 to n is equal to this expression. And this actually happens to be a true statement, which will be proven at the end of the next lecture. The next one, this one, you probably recognize this as an application of the formula for the square of a difference, right? You have the square for the first one minus doubled product plus the square of the second one. So this is also a statement about a natural number, which is true for all the natural numbers. The next one, n is equal to n plus 1, is obviously always false, right? Because you know that you can you can subtract n from both sides of this equation, and then you will get a result 0 is equal to 1, which is nonsense. And the last one, which I wanted to show you, this tells you that n is divisible by 6, and it is obviously true for some natural numbers, but definitely not for all of them, because it's not true for n equal to 7, right? 7 is not divisible by 6, but it is true statement for 12, because 12 is divisible by 6. So now you have seen several examples of such statements, T of n for natural numbers n. These which I marked in green are true for all natural numbers. These I marked in red are false for all natural numbers, and this one is true for some natural numbers and false for others. And in this, by induction, we will prove the truth of some statements, which will be true for all, or at least almost all natural numbers. And almost all means for some numbers for all the numbers starting with some particular number. And induction proofs are often compared to the domino effect. So keep this picture in mind, and I will come back to this. You maybe recognize this picture as the course image for this course. And in the next video, I will come back to this image, and I will explain the principle of mathematical induction. So stay tuned. Bye bye.